Hello, everyone. Welcome to the Space Policy Show. I'm Colleen Stover. Today is episode 104, Breaking Through in Space with Pete Worden. We have as our lead discussant the illustrious Dr. Angie Bukley. She's the technical fellow at Aerospace's Center for Space Policy and Strategy. And our special guest is Pete Worden. He needs almost no introduction. He's a retired brigadier general in the Air Force. He's a former NASA Ames director. He is the current chairman of Breakthrough Prize Foundation and executive director of the foundation's Breakthrough Initiatives. The list goes on. So let's jump right in. Angie, kick us off with the first question.
Thanks, Colleen. And Pete, thanks a lot for agreeing to be with us today. We're really excited about this. So let's start with the recent success of the DART mission. I know that you've got a long-standing interest in asteroids, commercial utilization of asteroids, and even planetary defense. So how does that look with you in the future? What do you think about the DART mission, and where do you think we might be going with commercial utilization of asteroids?
Well, let me start with the recent DART mission. Incredibly exciting. In fact, I feel a little bit vindicated. I've been, for decades, sort of maybe a bit of a voice in the wilderness of the importance of asteroids. And I got very excited about them in the probably 40, 50 years ago when it first became evident, at least to some people, that asteroids played a major role in evolution on our planet, that the demise of the dinosaurs was originally kind of an out there idea that was caused by asteroid impact, and now it's pretty much an accepted fact. I also got very excited as an astronomer with the asteroids are really the leftover bits and pieces of the formation of the solar system. So studying them, particularly up close, tells you something about the evolution of the solar system. And finally, and this is a little more recent, from about 30 years ago, the excitement of asteroids and their role of developing our space economy, particularly resources from asteroids.
Nice. Follow-up, you mentioned the asteroid that is thought to have killed a dinosaur. I read recently they found another crater that potentially there might have been two asteroids in fairly close succession that could have also contributed to that. Heard anything more about that?
Well, I think it's that was the KT Boundary Extinction, which was the last major extinction. There is still a considerable set of arguments about it, and it appears that it might have occurred over a period of hundreds of thousands of years, or even millions of years. That there was a series of events. Clearly, the largest part of that was the impact, which is now understood as the Chicxulub crater in just off the coast of Yucatan. But it looks like there were probably other things happening as well. There was massive volcanic activity that really changed the climate. And I have read that there are other craters that could have had something to do with it. So it may have been that the Earth was hit not by a rifle blast, but a shotgun blast of a number of things that were probably related.
And that makes me think of one more question. If we were to identify an asteroid that could be on a collision path with the Earth today, what could we do about it, if anything?
Well, that's an important question. And in fact, when I was in the Air Force, I actually managed to persuade the commander of the U.S. Space Command to take it forward as a new mission for the Defense Department to protect us against asteroids. Unfortunately, that effort failed in the Senior Defense Policy Council and the Joint Staff's Requirements Board, because I understood the Marines thought it was an Air Force trick to try to get more money, and that's always a problem. But I guess the good news is now that people recognize that something needs to be done. Interesting to me, a lot of people like to focus on the weapon, that's how you move it. It's actually much more important to figure out, how do we know there's a threat? Can we find it early enough? before you think about what you do about something, you need to first understand it well enough. So I think the most important thing is surveying space, understanding there's something on a collision course with us. And probably one of the most important things is what I call command and control. Who decides to do something, who pays for it, and maybe in the end, who gets blamed when it doesn't work.
Which will be a moot point if an asteroid of significant size hits the Earth. So,
yeah.
Over to you, Colleen.
Well, yeah, that's this is the stuff of science fiction movies, right? We've seen it over and over again, and so it's really kind of brought that whole idea of planetary defense into the public eye, more so from even when you were discussing it in the Air Force, Pete. Yeah. So just kind of bringing it a little bit more forward, continuing to. Pete, you were involved in the kind of rebirthing of the National Space Council. So why do you think this element of the executive branch is so important? What are they doing right? What opportunities might still exist with them?
Well, the National Space Council, I think, is an incredibly important effort. I mean, it's a recognition that in some sense, space, the economic implications, the security implications, and quite frankly, the inspiration implications are worthy of a coordination body at the White House level. And in some sense, it's as important as the National Security Council. And it's taken a while, of course, during the 60s when space was basically a national security issue. It was the National Air and Space Council was extremely important. And then in the first Bush administration, it was reconstituted when I was privileged to be a staff member on it. And then, of course, in the Trump administration and now in the Biden administration, it has been continued. I think this is an important effort. It's equivalent, as I said, to the National Security Council, National Economic Councils, and so forth, because it's not so much as the direction of it, but it's the coordination, because so many different government agencies have huge roles to play, and often they don't talk to each other. I know it may be a surprise to anybody, but we don't have a unified government, and it's an incredibly important aspect. And much of what we did when I was there and what they do now is just trying to get the Department of Commerce to talk to NASA, to talk to the Department of Defense, to talk to the Department of Energy, and that's really important, and I think it's working.
Yeah, and the fact that it kind of was elevated to be led by the vice president really kind of shows how important it is for the nation. Yeah, I like it. So talking about, I know that's kind of talking about more of a United States focused thing, but I know Angie had something that's broadening the view, right?
Yeah, and Pete, we know that you're an advisor to the Luxembourg Space Agency, and I know personally that you've always emphasized the importance of international cooperation. We go back a ways through the International Space University and our support of that activity. Talk a little bit about your view on the importance of international cooperation and maybe some of the things that need to happen to improve cooperation, on a global scale.
It's been a really exciting thing. In fact, I'm actually now a resident in Luxembourg. I spend 2/3 of my time there. And of course, the question first get is, why little Luxembourg? First of all, there's a number of reasons. One, it's the richest per capita country on Earth. And second, it has a long history of space. And in the 1980s, the Luxembourg government took a real risk and actually founded SES, that is now one of the world's largest commercial communications companies. When I was the director of NASA Ames, I had a Luxembourg postdoctoral fellow, and he said I should go visit Luxembourg, which I said, really? That's that little country that you get cheap gas and cheap booze between Germany, France, and Belgium. And he said, yes, they really were interested. And I ended up meeting with the deputy prime minister. And he at first thought I was nuts because I was talking about space mining. But we had a series of workshops, and they now have started a major program. There's over 80 startups in Luxembourg. They've done a lot, but I think the important thing is to understand that space is global, and there's a lot of things that non-traditional parties can do. Luxembourg, for example, believes by the end of this decade, 10% of its gross national product will be space, and a lot of the problems that somebody has. There's people interested in space every place I've been, and but there's not a lot of opportunities. So that talent isn't just limited to the United States, and I think it's important to understand that how many different countries are now understanding that space is an economic element. I'll even tell you what. I've been working for the last couple of years with the Kingdom of Bhutan, which you wouldn't think is a great space power, but the king there, who has actually become a very good friend, is using space to inspire the next generation to study science and math, and quite successfully. They've launched some satellites, and actually we've helped them build some small telescopes that have inspired people. So I think the message is space is global. Some of these smaller countries can help coordinate a better understanding and a better set of rules of the road around the world, and the inspiration for young people is really part of our whole future. So I'm very excited about it, and want to spend as much time as I can making space a global endeavor, not just a few nations.
Yeah, that's excellent. I agree with you 100%. I think collaboration is hugely important. Inspiring the next generation globally is very important. Maintaining that talent base is critical to the success of the enterprise as we go forward. So let's. I'm going to hand it over to Colleen. I know she had a question about something that's really forward-looking.
Well, so yeah, I wanted to just go back before moving on, though, that what could be done in the U.S. better? I mean, the United States has such a large financial footprint in space. What could the U.S. be doing better to try to encourage that international cooperation and be building up the kind of global interest, whether it's at the kind of new startups or at the government level? Or do you have any ideas on that?
The United States does a great job, but I'll tell you, there's one thing that and I may get a little controversy here, but I think that we have an excessive attention to export control, and export control is certainly something we need to pay attention to. But when it stops getting young people from around the world being able to come to the U.S., or the U.S. companies and entities working with others, it's a huge burden. Now, I know it's gotten a lot easier, but it is still a major issue that it stops really the U.S. companies from effectively becoming global companies. Other companies in places like Europe and Asia from really working in the U.S. And I think this is a huge break. So I would say that continued attention to understanding it's a global effort. Now, that has to be balanced, of course, against the security issues. Space is key, I think, to our national security. I was really pleased to see that we formed a Space Force a few years ago, and I think that helps. But I would say that we need to be careful that we don't strangle the commercial development in sort of foolishly applying export laws.
Yeah,
Absolutely.
That's not the first time I've heard that about how export control can really hinder innovation on a global scale, especially for our commercial entities in the U.S. and overseas.
Well, and Colleen, just understanding it, just as these commercial startups get going, just understanding the laws, it's a challenge. You almost have to have somebody just dealing with that all the time, just to make sure you're in compliance. So
yeah, if I can just add that we've done that. I run a global foundation that does a lot of space things. That we have a permanent consultant we talk to all the time about making sure we abide by these. That doesn't mean it can't be simplified and made a little more user friendly.
Definitely room for that.
Yeah, and maybe that's something that needs to happen on the US side in terms of having a one-stop shop for new startups who can't necessarily afford a specialist in export control. Yeah. So, breakthrough starshot, Pete, is something that's been progressing. And so I wanted you to talk about that a little bit. There's probably people on the show or viewers that are not really familiar with the concept. So can you kind of give an overview of the concept, and then tell us what's going on and how you guys are progressing?
It turns out that Breakthrough Starshot is part of an overall effort of what we call the Breakthrough Initiative. It was a privately funded effort with several $100 million committed, is to address to me, what the most exciting questions of science are, is life in the universe. And there's really three parts of it, and we can talk about all of them. The first part is there life anywhere? And, of course, remind everybody we don't know of any life outside of Earth. Second is there intelligent life anywhere? And of course, usually when I get asked, there's a question, is there intelligent life on Earth? And my sort of glib answer is that it depends how close you are to a national capital, whether you can find it.
Well, and the average human only uses 25% of their brain, right? Whatever.
But the third one is probably to me the most exciting, and is, can we travel interstellar distances, and particularly can we send probes? I always found our solar system a little boring. When I was 5 years old, my mother gave me the first books to read, and one was called Stars, and one was called Planets. And the planets one I thought was kind of boring. The planets all, okay, they were made of gas and rock and so on, and there was no cool aliens. And but the stars one said there might be other solar systems, and that might have all sorts of cool things. And indeed, we're now finding that just about every star has a solar system. So Breakthrough Starshot is an initiative started about 7 years ago that it was announced in New York at the New World Trade Center by our principal sponsor, Yuri Milner, as well as Stephen Hawking, who was our principal science advisor until he passed away. But the idea was, can we figure out this century how to send small probes to the next nearest star system? Now, that's a hard job. The nearest star system is 300,000 times further away than the sun. So if we want to get there in a few years or even a few decades, you need to go 1,000 times faster. We had some major studies, and a number of people, particularly Professor Philip Lubin at University of California, Santa Barbara, figured out that an older idea, that if we can take a really tiny spacecraft, weighing a few grams, attach a light sail to it, which is maybe 5 or 10 meters across, a very light material, and then hit it with a really powerful laser. And when I say powerful, I mean powerful, 100 gigawatts of power. That if we could keep that beam on it, and the laser would come from the ground, we could accelerate this small sailcraft over the space of a half hour to an hour to 20% the speed of light, and we would get to the nearest star system in about 25 years. And then we'd be able to take images and other data of any planets that are there, and then use a small laser to send that signal back. A very ambitious effort. We're almost complete with our first phase, and we're convinced that this is doable. We are looking at what the next steps would be, which I think are actually working on the sailcraft. I've gotten very excited about light sails. Indeed, I think the era of sailing ships in the solar system is about to begin. We think we can go everywhere in the solar system using sunlight, and then use lasers to go interstellar. So a very exciting effort. To me, it's the thing that really gets me out of bed early in the morning and keeps me up late to figure out how to do it.
Yeah, Aerospace has we have a program, I'm blanking on the name of it, but it's the solar sails, and kind of sending sending them out. It's in its early stages, but it's the exoplanet kind of research as well. So yeah, that's really exciting. So what you said that you finished the first phase. What does the first phase look like? What was the highlight of that?
Well, the first phase was of Starshot was to figure out, there's probably 30 major questions, but we prioritized 3 or 4 above all others. The first one was, can you build a laser that's 100 gigawatts of power, and is it affordable? That one's still a bit of a challenge, but we think that we'd like to get the cost of that down to sort of what the James Webb Space Telescope cost, roughly $10 billion. We're probably a factor of 3 or 4 off, but with some promising directions. The second one is, can you build the sail material that can take 100 gigawatts of power? That one actually looks pretty good. The Professor Harry Atwater of Caltech has been leading that for us, and that's actually looks very, very good. In fact, those are the same kind of technology that'll power things going through our solar system. The third one, which is to my mind maybe the hardest, is how do you communicate back from Alpha Centauri? And we've looked at using a small laser on the sailcraft. Professor Phil Mauskopf of Arizona State University is leading that for us, and it looks that can be done. So we're writing a major report by the end of this year, and then we'll look at what the next phase is, what our phase 2 will be, and that's very much up to our sponsor. But I think that we'll be doing probably focusing a little bit more on the what we can do in the solar system and beginning to perfect these technologies in a stepwise manner. But it's very exciting. I think by the end of this century, we're going to see probes flying by the nearby star systems, particularly the Alpha Centauri system, which is the nearest star system. We're now finding a number of planets in that system. Very exciting system.
Yeah, how exciting would that be to be able to get a probe out there and then supplement what we're learning from James Webb with more detail, and maybe find some really interesting stuff out there. I think it's really, really exciting, and I'm happy that you guys are looking that way and looking forward into the future and how we can get ourselves out there, at least get probes out there so we can understand more about what's going on and address these important questions about, is there life anywhere else? I personally think there has to be, but that's just me.
Yeah.
Well, maybe I can talk a little bit about the Alpha Centauri system. There's 3 stars in the system. 2 of them are about the size of the sun. One's a little bigger, one's a little smaller, and they orbit around each other in an 80-year period. The third one's pretty far away, but it's what's called a red dwarf star. It's about 10% the mass of the sun and maybe only 1/10,000th the brightness. It's called Proxima Centauri. It turns out Proxima Centauri, for indirect means, we know it has 3 planets now, 2 of which appear to be more or less Earth-sized in the habitable zone, meaning they could have liquid water on the surface. Now, the 2 solar-type stars are interesting because it could be more Earth-like. Alpha Centauri A, we had a program that's the biggest star. We had a program a few years ago with the European Southern Observatory. We have tentative evidence of a giant planet orbiting in the habitable zone of Alpha Centauri A. Now, what's cool about that is, if you're a science fiction geek like me, you remember the movie Avatar in 2009. It actually featured a giant planet in the habitable zone of Alpha Centauri A. That had moons, one of which was not only habitable, it was inhabited. So when we found the evidence of a giant planet, we got very excited, and our sponsor knew James Cameron, so we got a hold of James Cameron, who was busy filming Avatar 2, 3, and 4 in New Zealand, and he got very excited about it. So maybe we're going to find, a Pandora in the future as the moon of that planet. But we do have another satellite program that we've just started being built by the University of Sydney, that it's going to use a different method to see if we can prove that planet's there, and we're very excited about it. I think we're going to find there's lots of planets in the Alpha Centauri system, and that some of them are probably life bearing, and who knows, maybe even one of them has an intelligent species.
Who knows? And maybe we can talk about this in a few years and see what we've discovered.
So I want to push back just a little bit though. So Avatar is one of my favorite movies of all time, by the way. But what would you say to, so in terms of, there's obviously a commitment from different entities around the US, the world. There's a financial commitment for these kind of exploration initiatives. What about how that brings value to life on Earth, right? So there's kind of some pushback in terms of the spending that goes on for space and exploration and all that, versus things that are going on Earth, right? Hunger, climate change, war, and there is an element of people that kind of think, well, we shouldn't be doing the stuff in space. We need to take care of home first. What would you say to them in terms of how these things bring value to life on Earth?
Well, I understand that there's a lot of challenges. I mean, you can always say that whatever you're doing, you could say that why are we spending money on art or even basic science? But let me give the rationale to me, and it turns out there's probably four basic rationale for space. The first one is probably the oldest one, that it was related to national pride and power. This is clearly what Apollo was all about. And that remains an important thing. You see countries around the world that are inspiring their people because we're proud to be a Luxembourger because they're doing cool things in space. The second one is really about knowledge, about science and scientific knowledge. You never know what its value is. I mean, this is what Carl Sagan talked about on understanding the universe we live in, and the knowledge can help us solve some of these other problems. The third one is really about making life better on Earth, and this is a significant one. And from this one is where resources from space could potentially supplement what we have on Earth. There are people that like Jeff Bezos that wants to put space colonies that could have much better opportunities for living and bringing wealth and power back to the Earth. I think one of the ideas there is if we moved heavy industry off our planet, that's a good thing for solving a lot of these other problems. And I could even say that, and I know this is highly controversial, but I think that there's something called solar geoengineering where you could adjust the amount of sunlight hitting the planet. And that probably a whole another topic. But let me give you the fourth justification, which is the one that means something for me. And that's that a lot of people, and I think probably all of us and many of the people I work with, are really inspired by exploration, by the adventure of seeing something nobody ever saw before. These are the reason that people, explored the bottom of the ocean. It's the reason that we went to the moon, and it's what's over the next mountain range. This is, I think, what makes life worth living, and it's a cultural and philosophical meaning. And to me, that's meaning enough. And so I don't want to, argue that the other things aren't important, but for me, that's what's important. And I think for a lot of other people working on space.
Yeah, great answer. Thank you.
Yeah, thanks for that. So let's bring things a little bit closer to the Earth. Talk about the commercial enterprise, the commercial space enterprise, and how things are changing so fast. I mean, it's gotten to where it's really hard to keep up with all the news starts, with all the current activities, mergers and acquisitions, SPACs, and even the news starts that don't make it. I mean, we're seeing a lot of companies that have been around actually for a number of years that are that are declaring bankruptcy and going out of business. Just from your perspective, what's your take on the roles that commercial companies are taking, and especially with regard to human spaceflight?
Yeah, I think this is a sign of a very robust area, one that has an unlimited expansion potential, and there's always sort of false starts. And in fact, I remember when I talk to investors, they tell me that 9 out of 10 startups, go bust. So I think space has been more successful than that. So I think it's a vibrant economic activity, and it's really an unlimited effort. Right now, I think a lot of the excitement is in Earth observation, communications, but it's beginning to be in humans in space as well. Whether it's space tourism or space manufacturing that has humans involved, this is a huge booming market. And basically, I think it's a booming market because if it was cheap enough, every one of us would want to go, I think, or a lot of us would. If I could figure out some way to fly on Blue Origin or Virgin Galactic, I would do it. I probably have enough money to do it, but my wife says that if I go, she's going to go too. So that's double the price. But I think that's a really important thing. But to me, it's just the first step. The next step is going to be human expansion. I think we'll see lunar settlements by the end of this decade, where cislunar space becomes the key thing. This is really the regime where you're starting to use space resources to enable things. I think, as I said, within 10 years, we'll probably see 1,000 people on the moon or more. So, and then a little bit later on Mars. But so we're just seeing the first phase now. We're still fiddling around, with what we can get in the harbor and so on. But we're about to go into the deep ocean.
So you just said 1,000 people on the moon by the end of the decade? Did I hear you correctly?
Yep, that's correct. I think that's going to happen, maybe even sooner. And it'll be largely led, I believe, by some of these commercial endeavors. That the people leading these things are, to be sure, they're interested in making money, but they're also interested in establishing an unlimited future for humanity, and that's the first step.
Yeah. Well, and there are 6 companies right now that are developing or have plans to develop LEO destinations, low Earth orbit destinations, or commercial space stations. There's Axiom, Blue Origin, NanoRacks, Orbital Assembly, Northrop Grumman, and a new one that I just read about, VAST. And Orbital Assembly and VAST have plans for developing space stations that generate artificial gravity. Which would really open the aperture as to what you could do in terms of humans in space. I mean, there's still some obstacles to overcome, but how do you see this aspect evolving? Because we know the space station's going to be deorbited 2031 timeframe. There could also be a vibrant economy, if you will, in low Earth orbit, assuming that we don't mess it up to the point where we can't use it. But what do you think about this? How do you think? I guess what would it take for a commercial company to have a successful endeavor in low Earth orbit in terms of a space station? Who would be their customer base, and how would they close a business case around that?
Well, there's a lot of different options, and indeed, each one of them have different approaches. I think. In some sense, there's space manufacturing. I think biology, that's done in space, has a huge potential of bringing various new products back to Earth. There's ideas about fiber optics, Z-band, and so on. So space manufacturing, to me, is a really big, important effort. But a second, I think it's the first step to actually true settlement of space. And I'm glad you mentioned the artificial gravity. I mean, any of us that read science fiction felt that that's the only way to build space stations anyhow. I mean, Wernher von Braun's ideas in the 50s made that clear. So I think it's about time. My biggest criticism of the International Space Station is we never built the human-rated centrifuge. I think that will truly enable humans to live and expand in space. But most of these people I've talked to from these companies, their real interest is this is the first step to true space settlement, whether it's a standalone, very large, like the, Jerry O'Neill's colonies, these large, kilometer-long structures that could have hundreds of thousands or millions, or the moon, and then eventually to Mars. I think the idea that we'll learn how to do that in low Earth orbit, we'll learn how to make things in space, we'll learn how to live there with artificial gravity, and quite frankly, a lot of people would be willing to spend, a fair bit of money just to go be a space tourist. I certainly would.
Sorry. Angie's dog wants to go too, as apparently.
She does. So
That's an important point about animals. We're humans and we live with animals. We need to bring those animals with us to space. And so that's one of the things I think can be done on commercial space stations, that I'm really looking for for people to bring their pets and their, helpmeets.
Right.
yeah, oh, absolutely. I've done a lot of parabolic flight missions, but I've also read that they've actually taken cats on parabolic flights just to see how they would respond, and they're remarkably adaptive. And I can't imagine going to live long term without the possibility of having our pets, are very close to my pet for sure. I think that would be awesome. One other question, since this is a sort of a policy show, what do you see, or do you see, as the long poles with regard to policy and regulation in helping to get this low Earth orbit economy going, as well as moving out into cislunar and beyond?
Well, to me, I think that we've gotten the first steps that the indemnification and so forth that various countries have done, and starting really with the U.S. The second one is, and I think we're well along on it, is the ownership of resources in space. That whereas the Outer Space Treaty prohibits governments from owning things, it certainly doesn't prohibit, by any reading that I've done, and most experts now think, that it doesn't prohibit us extracting resources and beginning to develop the opportunity for people to live and use resources in space and eventually settle other worlds. So to me, I think that the next big effort is to develop rules of the road and protocols of how do we deal with each other? How do we deal with resources? How do we deal with conflicting claims? And how we're going to guarantee security. I mean, that's an important thing. If you make big investments deep in space, who guarantees the security for it? And these are very much a global effort, and I think we've made a good start on it.
Great.
Yeah, that's interesting. It's not a surprise that the long poles in the tent are about human cooperation over ownership and security. So we've got just about 5 minutes left. I wanted to offer a kind of fun question at the end here, but did you have anything else that you wanted to mention today that you haven't talked about? I know that cislunar is very near and dear to you. Did you have anything that you wanted to just come home with?
Well, obviously one of the questions you always get asked is, because one of our programs is to look for alien signals. And I know everybody, is very interested in that topic. I mean, I can tell you that we haven't found any, and we're spending a lot of money on it. Although 2 years ago we thought we had found the first one. It actually came from Proxima Centauri, which we now know has a couple, possibly habitable planets. It turned out to be human interference, but I think that this is one that's very exciting to a lot of people, and it's probably worth a whole separate discussion. But I just want to raise that the search for life includes the search for intelligent life.
Yeah, absolutely. So the question I had, I know you're from Michigan originally. You went to U of M, and that's okay because I was Michigan State, so I forgive you. But just in terms of, from these humble beginnings in Michigan, do you have any lessons learned or advice that you might give young space science students? Or
Sure, it's fine to go to Michigan State as long as it wasn't Ohio State. I think I grew up in the 50s and 60s. I grew up near Detroit, which was at that time one of the richest per capita cities in the United States, and it had seen dark days, but now it's seeing better days. But I think my key thing is that the opportunities, particularly in the heartland, of you can do anything you want, you can be anything you want, and the opportunities to go and study space was to me hugely exciting. And as a Michigander, I'm really pleased that so much really cool stuff has been done at Michigan. I mean, I have to say there's kind of a story here that a few years ago, I think it was in 2016, there was the 100th anniversary of the University of Michigan's aeronautical or engineering program, later became aerospace engineering. And arguably it was the oldest aeronautical engineering program in the United States. And as a Michigan grad and a former director of NASA Ames, I was invited to come to the ceremony. And when I got there, the host said to me, took me aside and said, "What year did you graduate? We can't find your name in any one of the lists here." And I said, "Well, that's because I didn't graduate from aeronautics. My undergraduate degree was in astronomy. It was class of 71, and astronomy was not a Johnny come lately. It was 1842 when the astronomy department was started. So I think it was kind of cool for me to say I wanted to welcome a junior department to their second century. But sort of the gist of this story is space in astronomy is a very old history in the United States, and among the oldest places is these major universities in the Midwest, like Michigan. So if you're lucky enough to live in those places, you've got a good start.
No, that's great. So yeah, you never know where you're going to end up, right? Shoot for the stars, and if you reach the moon, you've made it. So.
I can say the same as someone from Mississippi. You can do what you have the energy to do. Set your mind to it. Pete, it's been absolutely wonderful talking to you. Thanks for taking the time. Maybe we'll have you back in a few years to see where things have progressed. Any parting comments?
No, maybe we'll find alien signals by then, or find some life-bearing planets around nearby stars. Who knows?
Who knows?
Yeah, thank you guys. Both of you were great today's show. And Pete, we're so honored that you could join us today. You gave lots of food for thought, including, you heard it here, viewers, 1,000 people living on the moon and by the end of the decade. So when it happens, you can come back here and credit the Space Policy Show
first.
That's right. So everyone, please go to our website, csps.aerospace.org/Space Policy Show. From there, you can subscribe to our newsletter, get information on upcoming shows, as well as our research papers. Follow us on your favorite podcast platform. And if video is more of your jam, you can look for us on YouTube, because we've got our own channel now. So thanks for joining. Bye.